So this is the assignment 7 regarding the hashing. So the first question is a hash table that hashes all values to the same slot is essentially equivalent to what other data structure? So this is basically it is equivalent to linked list data structure. So this is when we try to avoid that collision using this separate chaining method. So we'll be creating this linked list data structure at that particular location. So whenever the collision occurs, so that new value having will be linked to that the previous value which is stored at that particular location, means at that particular hash value. So the answer is linked list data structure. The second question is regarding the hashing functions. So first function that we discussed is lose lose. So here are the benefits of that function, that it is extremely simple function to get the hash, and it could have been much better without sacrificing its extreme simplicity. Okay, it is now found mixed with other respectable code. Okay, so the main benefit is it is very simple to find the hash. It is the like a very simple method, and the drawbacks are like many programmers use this function without actually testing it. Okay, so that is one drawback, and there are a lot of collisions if we use this method. So and there's that one, and retrieving an element is also very slow. Okay, so that is another one, and yeah. So the next function is rs hash function. So the benefits is it's actually basically the bit optimization of this lose lose function, so that we can speed up the hashing process. Okay, and the hash generated by this method is of 32 bits in length. Okay, and then drawbacks is transversal in order by key is very slow, and selection in the range of keys is also very slow. So these are the drawbacks for this rs hash. And then the next function is djb2. So in this the benefits is it has excellent contribution and speed on many different sets of keys and table sizes. Okay, and the hash function generates very different hash values for similar strings. Okay, so the the drawbacks are probability of that collision will increase with the amount of data. Okay, a large number of hash functions do not have the ability to move to the next or previous data set. So this is for the DJB2 method, and then next is the SDBM hashing function. So the benefits is it was found to do well in scrambling bits. Okay, causing better distribution of the keys and fewer splits. It also helps to be a good general hashing function with good distribution. It seems to work well in situations where there is a high variance in the MSBs of the elements, the most significant bits of the elements in the data set. Okay, the drawbacks is hash table does not allow null values, and the hash collisions are practically unavoidable. So these are the drawbacks. Uh, So the next question is regarding collision, resolving the collisions. So first method to resolve collision is the separate chaining. So basically here, as we discussed in the first question, that whenever there is a collision occur, we'll be creating a linked list. That means if at particular location, at the particular value of hash, there is already one value present. So what we'll be doing is that value, and that particular value will be creating uh, linked list. So this value will be pointing to the new value which is having the same hash value. Okay, so basically we'll be creating a linked list from that particular hash value where this collision has occurred. So this is the separate chaining. So since we are creating a linked list, means it's kind of chaining. So that's why it is named as chaining. Okay, and the advantages is it is easy to implement, and the hash table never fills full, so that we can add more elements to the chain. As we can add n number of elements to the like linked list. Okay, it is less sensitive to function of the hashing. Okay. And then the next method is open addressing. So open addressing is actually divided like it is of three types. One is linear probing, quadratic probing, and double probing, double hashing. Okay, so linear probing is whenever we encounter this collision, we'll be checking the next address location to store this new value. We'll be checking is in a linear fashion the next address only. So if it is the last location, then it will come to the first location and then starts checking the empty location from the beginning in a linear fashion. And whenever like an empty location is found, it will assign that value to that particular location. So this is linear probing. Advantages is linear probing requires very less memory. It is less complex and it is simpler to implement. Okay. And the disadvantage is linear probing causes a scenario called primary clustering, in which there are large block of occupied cells within the hash table. Okay, since will be all the memory locations will be filled as like whenever the collision occurs, as soon as a new new address location, the next location which is empty, it will be filled with the new value. So it is like a like cluster of occupied data occupied it is some occupied cells. Okay. And then the next type is quadratic probing. So quadratic probing is how we in linear probing we used to go in a linear fashion the next consecutive memory location we need to check. In quadratic probing we will go through a quadratic function to check the next memory location. Will not go through that linear fashion. So this is the difference between that quadratic probing. So the advantages is quadratic probing is less likely to have problem of primary clustering that we faced in linear fashion, linear probing. Okay, and and it is easier to implement than double hashing, which is the next type. Okay, and disadvantages is quadratic probing has secondary clustering. This occurs when two keys hash to the same location. They have the same probe sequence. So it may take many attempts before an insertion being made. Okay. So like basically, so the condition is if the hash location is same and the probe sequence is also same, it will take like a lot of time to find a new location which is empty to fill the new value. Okay, and the other one is probe sequence do not probe all location in the table. Okay, so this is because of we are having that quadratic expression with which will be finding the location, the new location of the value for the values to be stored. So the third method to avoid this collision is double hashing. So basically, it is also a collision resolution technique, which when two different values to be searched for produce the same hash key. Okay. So basically here it uses one hash value generated by the function as a starting point and then increments the position by the internal by interval which is decided by using another hash function. Okay, so here we'll be having two hash functions. So with this, initially we'll be using the first hash functions. If the hash value which is produced by the first hash function is occupied, then we'll be using the second hash function to get the new value. Okay, so the advantage is double hashing finally overcomes the problem of clustering issue. Okay, since we are having two hash functions. Okay, and the disadvantages hashing is more difficult to implement than any other double hashing. Okay, so double hashing can cause thrashing as well. Okay, now come to the next question, which is regarding the resizing of uh, the hash table. So resizing a hash table consists of choosing new hash function to map. Okay, so whenever resizing is happening, we need to put this old values to the new locations in the new table. So that is a requirement. We have to insert this into a completely new table now, as with the resized of the table. The size is resized. Okay, so consider so here for this we are considering a hash table that resolves collision using chaining method. Okay, so we will double the size of the hash table whenever we make an insertion operation. Okay, that results in the load balance exceeding 1. So that is the size is n is greater than m. Okay, these are the sizes. So we will have the size of the hash table whenever we make a delete operation. Okay. So for inserting, we are doubling the size. Whenever we delete operation, we are halving the size of the hash table. Okay. So that results in the load balance falling beneath 1/4. That is, n is less than m by 4. So this approach show that the average runtime of each insertion and deletion is still uh, of constant time. Okay. So this is the answers for the question given in the assignment. Thank you.